Good morning, everyone. My name is Xinmiao Qu from Mielune. The previous presentation was from my colleague. Today, I'll show you a small topic about how to find the farthest reachable point in a network using QGIS, Python, and NetworkX. In my work with river network analysis, I need to identify the main stream, which is essentially the longest water flow channel from my given point. However, the QGIS built-in network analysis tool have only about the shortest pathway algorithms, and there's no native tool for finding the longest path. The solution I presenting today use QGIS 3.4 and with NetworkX version 2.4, and I will only use the QGIS console. And now let me show you the workflow. First, I load the network geometries, whether they are roads, rivers, and any other line features, and convert them into a NetworkX graph structure. Each line segment will become the edge in the graph, and I use the segment's length as a edge weight. Next, I need to find the nearest point in the graph and to the starting point. This is important because the starting point might not exactly coincide with a node in the network. I simply iterate the through all nodes, calculate the distance, and identify the closest one. And then we use Dijkstra's algorithm to calculate the shortest path distance from the start node to all other reachable nodes in the network. This gives us a dictionary of cumulative distances. Then I identify the node with the maximum cumulative distance. This is the farthest reachable point. Finally, I extract the shortest path to reach this farthest node. Note that we are finding the most efficient road to the network's extremity, not a meandering longest path. We convert this path to the line string geometry that can be visualized in QGIS. Here's a practical example using river network data of Japan. The red line shows the main stream, the longest flow path from our starting point, where it's nearby the shore. This is exactly we needed for determining the main channel in hydrological analysis. And there's another example using the road network in Hokkaido, Japan. Starting with the center city Sapporo, the solution found that the farthest reachable by highway. This type of analysis is using for such as emergency responsible planning and understanding regional connectivity. However, if there are disconnect part of the network, they won't be included in the analysis. That is the shortage of this, I think. Okay, you can see the source code in my GitHub, and thank you for your attention today.